Hello and welcome back to week number 9 of our Applied Food Science course, and this week we're talking veggies. Love veggies. They're one of the best foods out there, not only for you, but the variety of flavors and cooking options is nearly limitless. So last week we talked about kind of what made plants plants. Why are they special? Why does it matter with our food? So this week we're going to go a little more in depth and do just a very quick survey of some of the big classes of vegetables that we see and unique properties and how that applies to our cooking of them. So let's start off with the most widely eaten class of vegetable in the entirety of America. Any guesses? You got it! It's potatoes! Potatoes are eaten wildly more than anything else on the North American continent, vegetable-wise. In fact, the average American, if you break it down, eats on average 1/3 of a pound of potatoes every single day, which is nothing compared to old Irish immigrants or people in Ireland that used to eat somewhere between 5 and 10 pounds of potatoes a day. Ridiculous. So why potatoes? Why are they so great to eat? Well, it turns out it has to do with what potatoes are. Now, let's just go back over real quick what makes up a plant, right? So down here at the bottom, we have the root. The root goes into the soil and anchors the plant and also pulls up all that moisture. Then we have the stem, which provides the structure, the vertical support, and also transports all those nutrients and vitamins and minerals and water from the soil up to the rest of the plant. We've got our leaves. These things are all about taking in sunlight and turning that into energy, specifically in the form of sugars. Then we've got our flowers, which are the reproductive organs of the plant that basically, serve to reproduce. And then these flowers will eventually turn into fruits, which then go on to create more plants. So what are potatoes? Well, potatoes are what are called tubers, which is actually not a root like a lot of people think. Said that last week, but it doesn't hurt to reiterate. They are a swollen stem. So right here at the base of the stem, what will happen is all of the sugars and other good stuff that the leaves make, well, the leaves only get sunlight that's really good for making sugars about 6 to 8 months out of the year, depending on where you live. So if this plant wants to survive through the winter, it's going to have to store that sugar somewhere. And that is where tubers come in. They are the bottom of the stem, and they basically all the sugar gets shipped down to them, and then they store it in starch molecules. And if you remember, those are those very branching sugar chains. What's great about that is that they pack a lot of energy. So all that starch in that potato has a huge amount of energy. So if you're looking for cheap food that's got a lot of energy, potatoes are totally the way to go. Now, the other thing with potatoes is they actually have a very high amount of vitamin C. And there's different debate as to why that is, but for us, that's just an added benefit. So let's talk about the kinds of potatoes. There are really two common there's a separation into two classes that we usually put potatoes in. There's mealy potatoes and there's waxy potatoes. So mealy potatoes are like your russets or your blue and purple varieties you might see at the store, or fingerlings. And the reason they're called mealy is that if we go back to our plant cell diagram from last time, all these cells are all stuck together, right? Their cell walls are pressed against each other. Well, when you heat up or you mash or agitate mealy potatoes, these cells will break apart. They actually separate from each other. And that's really good when we have an application, say, like mashed potatoes or frying potatoes or baked potatoes, because it gives you a really flaky texture to that inside because everything is coming apart. And that's good eats if that's what you want. Now, the other variety that we deal with are waxy potatoes. And the reason they're called waxy is because, again, going back to our plant cell, these cell walls are all stuck to each other. And when you heat them or agitate them, it's really hard to break these things apart. So they tend to stick together, and that creates this kind of sliminess to it. Now, sliminess sounds like a gross word, but we don't really mean it that way. Think of it more like if you enjoy like potato salad a lot, you want your cubes of potato to stay cubes of potato. You don't want this gluey mess all over the place. So usually waxy potatoes, which would be your red and white potatoes, they're much better for things like potato au gratin or potato salad, for example, things where you want the potatoes to stay in the shape that you cut them in. Now, there are applications where, especially in French cuisine, where you can take these waxy potatoes and you can mash them up and push them through a really fine sieve and get some really nice airiness to them, and they make pretty decent mashed potatoes, but that's a lot of work unless you're working at a very high-end restaurant. Otherwise, I'd recommend going with the mealy varieties for your mashers. So moving on, the next closest thing to potatoes is sweet potatoes. And now sweet potatoes actually kind of dominate the Asian vegetable market. In fact, sweet potatoes are the most commonly eaten vegetable in China. And they're very similar to potatoes. The main difference is that the sugar that's in there, the starch, remember starch and sugar are the same thing. Starch is just a chain of sugars. The starches in those sweet potatoes, there's actually enzymes in the sweet potatoes that break it down into smaller, sweeter pieces. You see, our tongues can't detect the sweetness of starch. That's why if you bite a potato, even though it's full of sugar, it doesn't taste sweet because they're all bound up together. But with a sweet potato, you can get these enzymes that will activate, especially when you cook, which is why a lot of sweet potato applications have you cooking them for very long, slow periods of time to increase that enzyme activity. But it'll break that starch apart into smaller pieces that are a lot sweeter and are really preferred for example, if you do, say, a baked sweet potato casserole with some brown sugar on there, it just plays really nicely with the sweetness. Now, the other thing about sweet potatoes is because they're orange, that orange, again, comes from our friend beta-carotene, which is the precursor or gets made into vitamin A once we ingest it. So a great source of vitamin A with the sweet potatoes, as well as vitamin C. So, moving on to carrots. So potatoes are unique in that really in the potato family, those are the only two things we eat. We really only eat the tuber, the lower swollen stem. Now the rest of these families we'll be talking about are all very similarly related genetically, but we eat different parts of the plant. Remember, there are different parts to this, and we don't just have to eat only one of the organs, okay? So carrots is a great example. The root is what we traditionally call a carrot. Now, parsnips are also part of the carrot family. And what's really distinct about carrots is that they are incredibly sweet. That is to say, they store their sugar not as starch. So yes, they are storing sugar, again, right? All the sugar comes down from the leaves and gets stored in the roots, okay? They store their sugar in the roots, but they store it as actual sugar, usually fructose, usually fructose. And we can, when we eat that, we actually taste the sweetness because the molecules are a lot smaller. Now, the other striking thing, of course, about the carrot family is their color. Bright orange, and you can get carrots in a whole rainbow of colors nowadays. And that color, again, orange, theme of the day comes from your good old buddy beta carotene. Now, beta carotene, again, it's that it becomes vitamin A once we eat it. And so carrots are actually the vegetable with the most beta carotene out of all vegetables, which makes them absolutely wonderful. And the other thing is that beta carotene, or vitamin A, is what we call a fat-soluble vitamin. And what that means is that if when you cook carrots, say for example when you boil them, that color will not come out because it likes fats and oils rather than water. And so one of the really nice things about cooking with carrots is that you can maintain that really bright, vibrant orange, especially when you boil them, even for long periods of time. That doesn't really happen with other brightly colored vegetables. So, moving on, above the root, we have the stem. And as it turns out, there are some plants in the carrot family where we can actually eat the stem. The main perpetrators here would be celery and fennel. I bet you didn't know. Celery is actually very closely related to carrots. This is essentially the stem, right? You would have the carrot portion right here. Now, that's not to say that if you found a celery stalk, you plucked it, there's going to be a carrot hanging off the bottom. They're a little bit different. Think of it like different breeds of, say, Labrador Retriever. You can have yellow labs and black labs and chocolate labs. And they're very closely related, but they're not exactly the same. Same thing with celery to carrots that we traditionally think of. Celery is part of the carrot family. However, it is not going to be the carrot that we usually think of eating. Now that said, let's talk about celery. Now celery is a really interesting vegetable in that it has very minimal nutritional value. Well, yeah, it's got a little bit of vitamin A, it's got some vitamin C in there. It's mostly water. In fact, about 90% water. But the big nutritional addition to your diet that celery can provide is the fibrousness of the cell walls which run up and down it. Now, celery is, of course, notorious for when you break it, it's got these real fibery connections, especially on the outside. Now, that fiber is really good for your diet, like we talked about last time. That fiber essentially will take bad stuff out with it and will help you digest simple sugars a lot slower for your body, okay? And that's primarily why celery does really end up being very good for you. Now, there's an argument that celery can be especially good because it takes more calories to chew and digest it than it provides for you. Now, I hope you recognize that before we've talked about things like calories and trying to simplify nutrition down to a single thing that matters. Okay, so while it may or may not be true, I'm not totally sure whether chewing and digesting celery takes more calories than actually it provides to you. Keep in mind that that's not the whole nutritional picture here. Okay, celery does have a lot to provide just of its own merit. So if you're doing it just because of the calories, I don't know. Think about everything. So, moving on, our next big category that we want to address is the lettuce family. Now, the lettuce family, most often, of course, we think of the leaves of the lettuce family. But let's back it up, right? Let's go from the ground up. Roots-wise, there is a root in the lettuce family. There are several, in fact, but probably the one you've heard of, if you've heard of it at all, is the sunchoke. Now, the sunchoke is called the sunchoke because it's actually very similar to an artichoke. That is to say that it's got a very sweet, mild, meaty flavor, and again, that comes from being the root. The sugar from the leaves gets pumped down to the root and gets stored in the root, and so it's got that innate sweetness. And it's got that kind of mild meatiness to it, which is very, very pleasant. Now, moving up from the root, we've got our stem. And there are lettuce family stems, which get swollen, and we store the sugars and starches in there instead of the root. Primarily the turnip and radish. Now, the turnip and radish are very similar genetically and just in their flavor and taste. The main difference is that radish has that really bright outer coating, its dermal tissue layer, if you remember that from last episode. But that red doesn't permeate through the inside. So if you peeled a radish and peeled a turnip, they would actually look really, really similar. And they're both actually very similar to potatoes at a molecular composition level. That is to say, they've got a lot of starch in there. They store a lot of energy there. They've got some vitamin C. However, they have a lot more water compared to starch than potatoes do, which gives them a really nice crispiness that people really like, say, on their salads. Moving on up past the bottom of the stem where this gets swollen, if you got the actual stem for a lettuce, that would be your rutabaga. Now, a rutabaga is a interesting plant, and we're not going to dwell on it too long. They talk about it a little more in your book, but essentially the idea is that a rutabaga is kind of a cross between multiple plant types, probably a turnip, and some other sort of leafy vegetable that were probably grown in close proximity and cross-pollinated, and you've got this rutabaga. So you've got this stem that is nice and starchy and has some good crunch to it that's very similar to, say, celery, but it's in the lettuce family, so you have a lot less of that fibrous backbone there. So moving up to the most commonly well-known part of lettuce, of course, is the leaves. Now, when it comes to the leaves, it's important to think of the different types of lettuce that we see. Now, there are mainly two types of lettuce, the head lettuce and the leaf lettuce. And the big difference here is that with head lettuce, the leaves kind of encapsulate everything on the inside. So only the outer leaves are exposed to the sun. Now, what that means for us is that the outer leaves are going to have a lot higher nutritional value because they're getting the sunlight, meaning two things. One, they're the primary producers of the sugar and the starch that we so desperately want from our vegetables. Two, they're going to have a lot more defense mechanisms, which, as we talked about before, can actually really serve to highlight and improve our flavor experience. Now, conversely, because there's this shield of leaves around the outside of that lettuce, that means that all of the head lettuce, all of the leaves on the inside of that head lettuce are going to have not a whole lot going for them. Basically, if you get yourself a head of iceberg lettuce, those inner leaves are practically white because they don't have any chlorophyll. They don't have any need to absorb sunlight. They're also basically just water sacs. So there's not a whole lot of nutritional value to them. There's some fiber there, which is nice. But other than that, there's not much. So, moving on to leaf lettuce. Leaf lettuce is definitely where it's at when it comes to nutrition. Now, leaf lettuce, obviously, it doesn't have that the crunch, the wateriness of, say, a head lettuce, but that trade-off gets you a much more nutritious overall package because with leaf lettuce, all the leaves are open to the sun at some extent, which means that all of them are going to have more sugars. They're going to have more defense chemicals, which, as we said again, are really what is good for us. That's the stuff in there that's really going to help us out. So leaf lettuce usually has much more vitamin A, vitamin C, which is great. Yum. Okay, so moving on from lettuce, let's keep going because next up we have a big family, the cabbages. My cabbages. So let's talk about cabbages. The cabbage family primarily revolves around the leafy versions of the cabbage. Now, the thing about cabbages is that they don't just include cabbage. There's also kale, and there's also Brussels sprouts. Now, when it comes to kale, and Brussels sprouts and cabbage, actually kale and cabbage are very similar, right? Brussels sprouts we know are just those little things, but they all have something in common, and that's their defense mechanism. You see, Brussels sprouts, cabbage, the whole cabbage family employs a very unique defense mechanism that we actually talked about last time. Now, if we look at a cabbage cell, which is going to look like all plant cells, what will happen is they'll have little pockets outside of this vacuole that contain really nice flavor compounds or flavor precursors, you could call them. And inside this vacuole or other storage devices, they'll have these enzymes. Now, when this gets damaged, the flavor enzymes will interact with the flavor molecules and they will change the flavor molecules to something else. Now, the reason this is important is that it's impossible for us to consume food without damaging the cells in some way, whether you're eating it raw and you just bite it and crush those cells, or if, say, you're cooking it and you heat it up and you cause those barriers to break down. Or if you cut it, any way you look at it, you're going to have a lot of flavor compounds flavor precursors interacting with their enzymes, and you're inevitably going to get these flavors. Now, some of them, especially with the cabbage, can be very bitter, especially with like kale and Brussels sprouts. In fact, Brussels sprouts is a very interesting study on this because naturally Brussels sprouts have very bitter compounds inside them, and so if you just ate a raw Brussels sprout, it would be really, really bitter, and we can get rid of that by cooking it, by heating it up. So if you heat up a Brussels sprout, you get rid of that initial bitterness. But when you heat a Brussels sprout, you're actually damaging that vacuole. You're releasing those enzymes, and some of those enzymes will interact with a separate compound and make it bitter. So as the original bitterness is going down, a new bitterness is coming up, which is why a lot of people don't like Brussels sprouts, because whether they're raw or they're cooked, they're very bitter. Now, the one way to really alleviate this is to boil them. Because both of these compounds are water soluble, meaning they will dissolve out into the water. So if you put these in water, spoiler alert, cut them in half first, because a lot of this is in the insides, and if you just throw them in whole, it's not really going to penetrate that well. But if you cut them in half, you throw them in water, and you cook the crap out of them, all these bitter compounds will leach out, and then you can really do what you want. For me, my favorite is to do that, and then I put them on a baking sheet, a little olive oil, and just broil them, because you get that really nice browning on them. They're just delicious, a little bit crisp, awesome. But going back to cabbages and kale, they do have these bitter problems. Now, some of them you can solve by cooking them. Kale, specifically, if you boil it, again, you can get a lot of those bitter compounds to leach out. Cabbage, though, is has an interesting mechanism in that if you boil it for a little bit, a lot of those bitter compounds will leach out, which is good. However, if you overcook cabbage, there are other compounds in there that if you cook them for long enough, they'll start to clomb together. And that will produce this sulfur compound that we generally associate with kind of skunk smell. It's actually really close chemically to that. And that's why we generally think of old cabbage as really a gross smell. And it's because people cooked cabbage too long. So if you're going to cook cabbage, which can be really delicious, make sure you don't overdo it. Otherwise, you'll get those extra sulfur compounds there at the end. So, moving on. We've only got a few more. First, beets. So, I love beets, particularly dropping them whenever I can. But when we talk about where they are from on the plant, they come from the low stem again. They are a rhizome, okay? Very similar to tubers. There's some technical differences you don't need to worry about, but you need to know they are a stem, a low stem. And they... What makes beets so special, right, is that they have this compound in them called beeton. Clever name, right? And that is the coloring pigment of the beets. And what's interesting about beeton is that it holds relatively no nutritional value. Okay, it just makes them really bright, and it's also very water soluble. So if you cook beets in water, it will leach out of the cells. Now, beets have so much beeton that it's really hard to get beets to change color that much. But if you want to really preserve that bright red, you definitely don't want to cook them in water too much. Now, beets, again, they are the low stem, so that means they're storing a lot of that sugar from the leaves that the leaves make. They send it down to the roots or the low stem, and that's why beets are so darn sweet. Now, here's something I bet you didn't know. There's another member of the beet family that we eat regularly, and that is spinach. Spinach is actually part of the beet family. Again, if you pulled up spinach, there wouldn't be a beet on the end. It's just they're related. And spinach is one of the healthiest vegetables you can eat. First off, it passes our dark color test from last lecture. It is one of the deepest, darkest greens of any of the plants. But on top of that, it's got tons of vitamin A, vitamin C, and it's got a real nice sugar content. It's got great fiber to it. Spinach is just fantastic. There's just almost no way to go wrong with spinach. There is one thing though, and this applies to a lot of dark leafy greens like spinach. They contain calcium in really high levels and in a very specific compound that for some people predisposes them to kidney stones. And so eating a lot of spinach can actually lead to the formation of kidney stones. So if that's a problem in your family, maybe watch out for that a little bit or ask your doctor. They could probably tell you more. So moving on to our final class of vegetables we want to talk about, the alums, or the onions, the garlic, right? So these, you may have guessed it, are bulbs. They are lower stem, right? If you've ever pulled an onion out, you'll see the roots coming out of the bottom. So this is not a root. Again, this is a lower stem. But what's really interesting about the alliums is that they always have these layers to them. And that's just how they grow. It's a characteristic of them. There's some unique benefits and to that, but we're not going to go into that. What you do need to know is that all alliums have a very specific chemical defense system that's actually super similar to the cabbages. Again, they will have compounds floating around out here just in the cell, and then they'll have these enzymes either in the vacuole or little pockets floating around the cell, and the second these things get damaged, they will release those and they will interact and basically create a chemical bomb that will just really not be good for you. Mainly, it's sulfur containing compounds, and they release them into the air, which is really unique as a chemical defense mechanism. Most of the other plants that we've talked about, especially these vegetables, it's a chemical defense against the taste. So if someone bites into it, or an animal bites into the raw form, it's really bitter, it tastes horrible. But onions release this into the air. It's called aerosolizing. And not only that, but once they interact with the air, they can form even nastier stuff like hydrogen sulfide or sulfuric acid. Really mess you up, especially when they get into your eyes and interact with the moisture in your eyes. You get this reaction, and that's why you cry, because essentially this thing is tossing acid into your eyes, and that's no good at all. A few ways to combat this. These enzymes are much less active at cool temperatures. So if you take your onion and you throw it in an ice bath, or make sure you get it right out of the fridge before you cut it, make sure this thing is cold. You're going to get a lot less of that. Also, the sharper your knife is, the less damage you will do overall, and the less of that chemical nastiness you'll get. And the final thing, and this is I've heard, and I don't know how much I'd buy it, but hey, why not, is fire. Because these compounds have shown to be combustible. That is to say, if they're exposed to fire, they'll react with the fire in the presence of that heat and oxygen and form harmless compounds. So I've heard people say that, if you just put a candle right next to your onion while you're cutting it, or turn on a burner, that you can really alleviate some of that, but I don't know how well it works. Usually, if you just keep it cold, you use a sharp knife, you're not going to have to worry about a thing. Now, the last thing I want to talk about is in that onion family is garlic, one of the most delicious compounds or plants in the known kingdoms. And the reason it's so delicious is because it has the same chemical defenses as the onion. They're just a lot less. The onion has about 10 to 40 times more of that compound than garlic does. And it's actually that sulfury compound that we love to eat, especially when you cook it. Now, one side note onto that is elephant garlic. Elephant garlic isn't actually part of the allium family. It's actually a leek. But it just resembles garlic in its shape, and that it's got little individual cloves. And also, it kind of has that garlicky taste to it. It's got a few of those sulfur compounds in there. However, it's definitely much more mild than regular garlic. So, with that, we're going to conclude our survey of vegetables. Keep an eye out for the bonus bit so you can get your lab, and we'll see you next time. Bye!